So I'm really excited to be teaching this course. This is I think my third time teaching it. Um, R Studio, I guess now it's Posit, did a little switcheroo on us. The first time we taught this, it was R Markdown, and then they introduced Quarto, I think like a week before our course started. So we have now, as you can see from the title of the course, sort of transitioned to Quarto, and I'll explain the differences between Quarto and R Markdown as we go along. But I'm super excited to teach this course. I'll go ahead and put up my slides and we'll get started. Let me make sure I get all this going. There we go. Okay. Always so many things to manage here. I'll make sure I can see any chat questions you have. Okay. So let's just talk about some basic course information before we get started. We're going to have morning and afternoon sessions. Well, I should say morning and afternoon, but of course we have people here from all over the world. And so I'm coming to you at 7 in the morning from the West Coast of the US, but I know people are coming from all over, but morning and afternoon for those East Coast people anyway. We will also, since the sessions are about 2.5 hours, we'll take a short break roughly in the middle point of each morning and afternoon session. Just a quick break for everybody. We're going to be going back and forth between our Studio R and the slides, because a lot of what we're going to do is sort of hands-on stuff. So we'll be going back and forth between slides and our Studio pretty frequently. There'll be that to manage as we go along. You're welcome to follow along if you want on your own system, depending how you're set up. Sometimes I find that can be distracting, not to me, but if you're trying to follow along, sometimes if you're trying to do it at the same time, it can be difficult. I'll show you in a second that anything that I work on, any worked example that you see me working on our Studio is going to be available online through GitHub for this course. So you'll be able to see eventually, not after the session's over, I'll make sure I'll push those things up. So you'll be able to see those things, anything we did. So you don't have to feel like you have to write this stuff down in order to capture it. But I know some people just like to do the hands-on to help them learn, and that's fine as well. When we work on stuff together, in general, I'm happy to address any questions, problems, or difficulties you have as they're coming up, as long as we have time permitting. I do want to make sure we get through all the material. But generally, we have a small enough course that I'm happy to pause and help people if they're having a difficulty with something, because I often find that helping you resolve a difficulty also helps other people see it, because they might be having the same problem or they might have that problem in the future. And so it's useful for them to see how those things are resolved as well. So feel free to raise your hand virtually here or put it on chat, any questions or difficulties you're having as we go up, and I can try to address those. I'll be keeping an eye on those as we go. You can also get help with problems asynchronously, and if you're someone who's watching this asynchronously, particularly if you're maybe in the wrong time zone today, you can also get help via the Slack workspace. So there should be instructions from Code Horizon on how to sign up for that Slack workspace, and I highly encourage you to do that. I'll be monitoring it pretty closely throughout the next 3 days. So if you have questions that arise when you're outside of class or when you're watching this thing asynchronously, you can go ahead and post your questions there, either to the general chat, or if you feel more comfortable direct messaging me, that's fine as well. And I'll respond to those questions. And I should say, I generally keep track of that well after the course is over. I think there's an official time I'm supposed to keep track of it, but I'm still occasionally answering questions from the first time I taught this course. I generally have Slack up when I work anyway. And so it's, you can get a hold of me through Slack long after the course is over. A little about me. Steve already introduced me, but I'm an associate professor here at the University of Oregon in sociology. My training is actually in demography, in the demography department at UC Berkeley. Most of the work I do involves statistical analysis of big surveys or census data. And I'm a big proponent of open science and research transparency. It's one of the reasons that I agreed to be an editor of our open access journal in Sociology Socius. And I'm fully committed to the idea that one of the best things about open science and research transparency is not just that it helps our communities, but it actually helps us be better researchers. It helps us think more carefully about what we're doing and why we're doing it and how we're doing it. And ever since I've adopted these practices, I've not only, I think, been a better researcher, but enjoyed myself more as well. And I love R. I've actually been using it since before it was even R. I used it back when it was S plus, or the precursor to R technically is S plus, and used it for many years before the R Studio and Tidyverse revolution, although I'm now pretty fully committed to that revolution, if you will. And I use R Markdown and now Quarto for just about everything I do. If I could write emails in it, I would. There actually was a package in R Markdown to write emails. Technically, I didn't go that far. I will tell you that, but so far no packages for that in Quarto, but who knows? We may see it down the road. Okay. So I talked about this briefly at the top, R Markdown versus Quarto. You may have heard of one of these, or you may be more familiar with one of these, not the other. So what is the difference between R Markdown and Quarto? And as I said, as I was preparing to teach this course for the first time in R Markdown, that is when Quarto dropped. And so that was an interesting experience, but we've now transitioned mostly to teaching this class in Quarto because I think Quarto is a significant improvement over R Markdown. So basically Quarto, you can think of Quarto in one way as next generation R Markdown. So R Markdown was the first attempt at this, and R Markdown was in many ways great, but it was also, as happens a lot of times with these systems, as people try to add more features to it that it wasn't ready for, it ended up getting complex, bloated. The syntax wasn't always consistent in how you did things. And so a lot of what Quarto is doing is cleaning that up and giving us a much cleaner interface to work with, a cleaner way of dealing with options and code chunks and things like that, that will make it easier to read and easier to work with. So that's one aspect of Quarto. But the other aspect of Quarto is that Quarto was intended to be a standalone program that didn't depend on R or RStudio or specific R libraries. That is, you don't even have to be running R or using R to use Quarto, because Quarto can use multiple programming languages. And the three biggest ones are R, Python, and Julia, but there are also a variety of other little things that it can do. For example, one thing, I don't think I have a slide on this, but I'm going to show you at some point on day 3 if we have time, is you can include charts and flow charts through the Mermaid formatting system directly into a Quarto document, and you can mix those things together. And so Quarto is both R Markdown and sort of independent of R, although it works well with R, obviously, because it's written by the people at RStudio. I should say POSIT. But it works also well with other programs. Now we're going to focus on R. I will show you at the end of today, I'll show you how to integrate, if you want to integrate Python into your documents. But most of the focus will be on R. The structure and syntax is very similar. So if you have some familiar with R Markdown, you're going to feel pretty comfortable in Quarto, but there are some changes, improvements, I think, in pretty much every case, in how you specify things in Quarto that make it better. And as I said, part of what it's doing is it's taking a lot of the bloat that happened with R Markdown, as everybody wanted to add features to R Markdown, and it's simplifying that, streamlining that, and then adding new additional features. And as we've seen it progress since I first started teaching this course, we've seen many new extensions to the basic Quarto that make it very exciting. So I'm pretty excited about where it's going in the future. I think it is the future of this. So we've pretty much transitioned to teaching all this in Quarto versus R Markdown. Now, it's still in active development, so you're going to see new features coming out all the time. Some of the stuff I say here, I don't think anything is going to be incorrect, but it may become dated over time as we see more and more stuff get developed for Quarto. Okay, let's talk about briefly about the outline of the course, and then we'll get going. So today is the basics. We're going to talk about what is Quarto? What are these reproducible reports that we're talking about? We're going to build a first Quarto document, and I'm going to show you the different parts of the Quarto document. We're going to talk about how Quarto actually works, what it's actually doing when you push the render button, behind the scenes, what's all involved, so you understand, particularly if you get an error, how to fix it. And then we're going to learn the various aspects of Quarto, the markdown syntax that allows you to write text, and then how to add R code through code chunks. That's what we'll do today. Tomorrow, we're going to focus on putting together a full report. So we're going to take those basics and learn how to write a full report, which may be for some of you a research manuscript that you want to submit to a journal. For others, it may be some kind of internal report or external report. But we want to basically figure out how to put figures in there that look nice with nice captions. We want to figure out how to produce nice tables. We want to figure out how to include citations in an automated way. We want to figure out how to make notations like footnotes and add mathematical notation. And we want to look at cross-referencing. So all of that will allow us to basically, at the end of tomorrow, we should be able to produce a full research document. And then on day 3, we're going to talk about extending Quarto. We're talking particularly about customizing the appearance of Quarto to make it work for your particular situation. And then we're going to talk about using Quarto in other ways beyond just the basic research document. Particularly, we're talking about making presentations, how to make websites, how to use Quarto projects, and how to publish your content. So that is the basic outline of where we'll go. Now, if there's something that you're particularly interested in learning, but it's not covered here, let me know through Slack or email, and I can figure out how to squeeze it in. There's some loose time in here that we can probably figure out how to get stuff in, and I want to make sure that this class is useful to what people need. So if there's something in particular you'd like to see, go ahead and let me know. Okay. And again, if you have questions, you can go ahead and raise your virtual hand or put it into chat, and I have an eye on those, so I'll be able to see them. So what are reproducible reports? Well, let me talk first about the traditional view of the research process, and what we're trying to do here is really turn that on its head on a couple different ways. And this is, implicitly, I think, not necessarily explicitly, but implicitly the way that many of us are taught to do things in graduate school by just following the way that our mentors are doing things, and not necessarily in the best way. So in the traditional view, you're doing your statistical analysis. That comes first. You do that analysis typically in some kind of script, or you should do it in scripts, whether those be R scripts or stata-do files or SAS scripts. You're writing scripts that are performing your analysis, including the data cleaning part of that analysis. Those scripts are going to create a variety of outputs. Those may be images when you're writing figures. Often it'll just be logs. So Stata, of course, loves to give you the log file where you have all your output of your models and everything else in the log file. You can do this sort of similar things with R and SAS. But in the end, you end up with all this statistical output. And then you segue over at some point to writing up your results. And this is considered sort of a different part of your workflow. A different skill set, different muscles are involved in writing up results than statistical analysis. You're also probably switching over to different kinds of programs on your computer, right? So you're going to use a word processing program like Microsoft Word, or maybe you're more savvy and use Google Docs these days, or OpenOffice or something like that, but you're using a word processing program to write up your results. And as part of writing up those results, you then have to take all that output that was produced from the statistical analysis, and you have to get it into the Word document, the word processing document. And so, for example, if you have a table that you need to make, let's say you have a bunch of models you've run, and you want to get all those model results into a table. Well, you have to create that table, and you have to transcribe your results from the output over to your write-up. And that for anyone who's done it, and most people here have probably done it, is a tedious process. Not terribly pleasant, but also importantly, a major place where errors can occur. Transcription errors, anybody can suffer from a transcription error. It's an easy mistake to make. And so we then have to check our results in triplicate to make sure that we didn't have any transcription errors as we're going. So let's talk about some of the problems with this approach. There's a lot of extra labor involved in that attempt to get our statistical results over into a word processing document. It's labor intensive. It's labor intensive to write out all the numbers that we want in the table. And that labor often then gets repeated because if we then go back and think we're at the final stage, so we're writing up and we're transcribing our results, and then we're like, oh, wait, no, I need to do this other thing, right? And we have to go back to our statistical analysis. We have to rerun our results. We have to add a variable to our models or something like that. And now everything is slightly different. Maybe not that different, but all the numbers are not the same. And so now we have to retranscribe all of that again anytime that we need to update our analysis. So even if you are at the final version, you send this paper out to a journal, they like it, but they want some changes. So you're going to make those changes, and now you're going to have to retranscribe everything. So you have this labor-intensive process of transcription. And you then have to repeat that process of transcription every time you have to reversion, update your project. Importantly, this can also lead to out-of-date output in the final product. So this is another source of error. Transcription errors are one problem. But the other problem is sometimes you may update the analysis, but forget to update all the figures and tables in your paper, and then you have out-of-date output in the final product that doesn't actually match the state of the project. And then in addition to extra labor and versioning, as I've already mentioned, the potential of errors is high here because this manual transcription is easy to lead. It's easy to lead to errors, and those errors are often difficult to catch because there's a lot of numbers that your eye has to go over to make sure everything is accurate. So why do we do this to ourselves? Here, we're going to suggest a different approach. This is the idea of reproducible reports. If we like chocolate and peanut butter, just to be clear, let me go back. That was peanut butter and chocolate. I'm not sure that those things are always peanut butter and chocolate, but okay. They're better together. So why switch? Why do we have to switch up our workflow to some different kind of process when we write up results? The idea of the reproducible report is that we're going to embed code within a logical markup document as opposed to a visual markup document. We'll explain what that means in a minute. And then we're going to process that code and markup to produce some final readable document in some format, whether that be a PDF file, an HTML document, or even a Microsoft Word document. And in this case, all the statistical output that ends up in our final product in the form of tables and figures is going to come directly from the code. We're not going to have to manually transcribe it. We're not going to have to manually take those figure images and drop them into our word processing document. We can be assured that every time we run this, that our results will always be accurate because it's being produced directly from the code. I mean, assuming the code is accurate, but that's a different issue. And it will be up to date. Everything will be up to date with the most recent version you have because there's no transcription involved. There's no updating required manually by you. This will happen automatically anytime you render the document. And so this is a little image from Allison Horst, who has all these great images for statistics stuff and R stuff. This is R Markdown, but the same is true of Quarto. This is a win for reproducibility. We know that we can always, and when I say reproducibility, I don't mean just in the sense that other people can reproduce your work, but you can reproduce your work because you know that it's coming directly from the code. It doesn't involve any of this invisible labor that we can't see, and yet it takes a lot of time. So a lot of benefits to this approach. Now, let's talk about this difference between visual and logical markup. Some of you may be familiar with logical markup if you've ever used LaTeX. but some of you may not. So I want to be clear about what we're doing here. So when we use a word processing document like Microsoft Word, we're using a visual markup system. So it looks like what it's going to look like when we print it, right? If I select a word and go up and hit the bold button, that word is going to look like it's bolded in my document. Okay. The margins of my document are going to match what it's going to look like if I were to print it. It's intended to be the same visually as if I was printing it. Okay. That's the layout that we're looking at. This is also called a WYSIWYG. What you see is what you get system that has become very common for these kinds of office-oriented documents. And for many reasons, and for many people, that makes sense. It's easier for them just to visualize what their ultimate document is going to look like by being able to see it on the screen. However, in a logical markup system, we let go of this desire that we need to see what the final document is going to look like as we're writing it. And instead of applying visual markup to our document, we apply logical markup to a basic plain text document. So our document is plain text, and we apply syntax that tells the program how we want something to be displayed. So instead of putting in a bold and an italic for words, I use, in this case, using the markdown markup system, I surround the word I want bolded with double asterisks and the word that I want emphasized with single asterisks. And when that gets processed, when that gets rendered, the final document will show those as a bold and an emphasis or an italics in the final document. But it won't show up that way in the actual document that I use to write it. Now, two of the most famous markup systems that you may or may not be familiar with, HTML, hypertext markup language, is what sort of runs the internet. That's what internet pages are actually coded in. And it used to be something that you could actually read if you opened it up, but things have become more complicated. If you look at the source code for HTML, it's very difficult to read it. There's so much markup that's been applied to it now. But more importantly for academics or researchers in general, the LaTeX system, or more generally the TeX system, which is spelled TEX, or for LaTeX, LATEX, looks like latex, but it's pronounced LaTeX usually, or sometimes it's pronounced LaTeX. I've never been quite clear on that. It's like stata versus, what is it? Stata versus stata? I don't know. Anyway. We just have one word over here, an R, or one letter. You can't screw that up. So TeX and LaTeX are logical markup systems that have been used to typeset research-oriented documents for a long time. I think TeX goes all the way back to the 1980s at least. And they have their own markup system. And some of you may already be familiar with them. And in fact, we're going to be sort of under the hood of Quarto using LaTeX and TeX. But LaTeX and TeX typically not as bad as HTML, but in modern iterations of them, if you try to look at a source document in LaTeX TeX, it can be a little difficult to read because the markup syntax that's added breaks the flow of reading the paper. And so instead, we're going to be using the Markdown system, which is why the original version of R Markdown was called R Markdown, which is this more modern logical markup system that is designed to be easy to read, that reading through a document that has been marked up with Markdown doesn't break the flow of your reading at all. It doesn't make it difficult to read, is intuitive and easy to learn. So we'll do that today. Later, we'll learn more about how to use the Markdown system. Okay, since I am someone committed to open science, I want to also emphasize that using reproducible reports really helps you think in an open science way. And I want to suggest to you that we often think of the traditional view of the research workflow sort of flows. We go from the raw data that we start with, right? So we start with some raw data. Now we may produce that raw data ourselves. You may be downloading extracts of raw data from other sources. That's what I typically do. But you have some raw data. You want to convert that raw data into analytical data, often by recoding variables, cleaning things up, subsetting, merging data, reshaping data, all the stuff we do to data wrangle to get from your raw data to your analytical data. And then you're going to take that analytical data, you're going to run some analysis, and you're going to get the output of that analysis. And then that output of the analysis is going to go into your final products. And the final products could be a research manuscript, could be presentations, could be posters, could be all of those things. But those are the final sort of public-facing documents that you're going to produce out of your research workflow. And this is more or less the way I was taught it in grad school, and I was taught to keep track of these things and to version them, like all my different log files and my output and all this stuff. And I want to tell you that this is, I think, a bad way to think about what you're doing. Let me just say real quick before I show you that one. The green is intended to be what is the important thing? What is the important thing in your project? Ultimately, here that we think of it as the final product. But I think in a more modern data science workflow way of thinking, there's an invisible part of this process, which is actually the important part. And that is the scripts that take us from each of these different points, right? So we have raw data. How do we get the analytical data from the raw data? We get it by scripting. We write a script that converts the raw data to analytical data. How do we get from the analytical data to output from the analysis? Well, we write scripts that analyze the data. And so at all of those points, it's actually the scripts that are what's real about our project. The scripts are what's important about our project, because we could delete everything we have. We could delete all the analytical data we've constructed. We could delete all the statistical output we've created. We could delete, ultimately, when we're using Quarto, we could delete even our research documents at the final products. And we could be confident that we can get all that stuff back by just rerunning our scripts. If we're following a good protocol, if we're actually doing this the right way, your script should be able to reproduce all the things that you may think of as the important part of your projects. And you can let go of all that stuff. You don't need to care about all that stuff. All that matters is that you have the raw data and you have the scripts that can produce all of the output. And seen from this perspective, the output, all of this stuff, the analytical data we produce, the output from our analysis, and even our final products, these aren't the products of our work. They're not things we need to worry about saving. They're actually danger points because they're artifacts of a particular run of our scripts that could easily be out of date. And so actually what we should do, anytime we want to make sure our project is up to date, we should just delete all of that stuff. Delete all your analytical data, delete all the output, delete all your final products, rerun all your scripts and reproduce it. And now you can be sure that everything you're producing is up to date. Okay, so what is real about your project? The raw data and the scripts are what is real about your project. Now, the difficulty with following this workflow through all the way for many people is this problem of transitioning to the writing it up phase of your research. So you may be able to use R scripts to organize your data from raw data to analytical data. You may be able to use R scripts to do your analysis. But for many people, they still transition to opening up a Word document to write the final paper. And now you're kind of in a different workflow. Now that paper is actually a real thing, and it's not being produced by a script programmatically. And so we have all the problems of that. So if we switch to using reproducible reports, then we're extending this principle of the script is what matters all the way to the end of your workflow, all the way to the final products. And we can be confident that everything we do, including the final products of our research, is reproducible by our scripts. Okay. So how can we use Quarto in our workflows? Well, the first thing I want to suggest is that you can use Quarto as a basic lab notebook. And I use it this way. So in this sense, you can often replace traditional R scripts with a Quarto document. And I have basically done this in all of my research at this point. So I used to have, the way I sort of organized my research, I used to have an organized data script that would read in raw data, do all the data cleaning, data organization, clean it up, just keep the variables I need, and save that as an analytical data set, right? So my organized data script went from the raw data to my analytical data. Did it all in a script, did a lot of checking to make sure I did things correctly. I've now transitioned to using a Quarto document to do that same process. And that makes it possible for me to make notations, to make comments that aren't actually R comments, but actually like textual comments, to output my checks as nice tables, and basically just improved the experience. It looks like I'm writing a lab notebook now. And I do the same thing for the analysis. So my analysis will be me describing what I'm finding as I do it. And you can do this in sort of a diary thing where you just, you can do it by day you do it, or you can do it, organize it by topically or however you like. But you can basically treat these as lab notebooks that follow your progress on a particular research project. Of course, we can use them for full reports, scholarly articles. That's what we'll be focusing on, particularly tomorrow. Probably the most important thing people think about using Quarto for. We can also use them for presentations. And in fact, the presentation that you're seeing is produced in Quarto. And they work, you can make beautiful, particularly HTML presentations using Quarto, following and using the same principles you would for a scholarly article. Everything is being programmatically produced through code. We can use them to do posters. Now, there used to be really good facilities in R Markdown for posters. Quarto is still in development, so I don't think have a good poster thing yet. But I'm sure that will be something we'll see develop soon. Websites. So we'll see on day 3 how to make a website out of Quarto, but you can even make your research project a website. So we'll talk about that, and I'll show you an example here in a minute. And you can even write books, full books in Quarto. Many of the tutorials you'll see online about how to use a particular thing in R have been written either previously in R Markdown and now in Quarto. And I have 2 books that I use myself that I've written for my students in my stats courses that use Quarto to show them how to do stuff. So let me break out of here and show you some of these, how these look in practice. So we're going to go back. Well, I guess, no, we can stay here because these are all going to be on here. So let me show you. Make that go away. All right. Well, actually, let me show you. We are going to break out of here for a second. So I'm going to show you a project that is very current, still ongoing. Go. So this is a project I'm working on with a couple other faculty members here at the University of Oregon. And it's already been sent off to a journal, so we have a full paper. So I'm going to go here. This is the full project, and it's actually set up as a Quarto project, which is something I'll talk about more on day 3. But because it's set up as a Quarto project, if I actually just go over to this build section right here, I can just click that render project button, and it will actually run through the entire thing. It'll delete all the products that we've created. And it will run through the analysis starting from the basic organized data script. Now, I'm not going to do that here because there's some multiple imputation, which will take a little while to run. That's what I want to slow us down here. But I will show you some parts of that. The other nice feature of this being a Quarto project is we have it set up so all the output goes to a separate folder, so we don't get our output cluttering up our actual code. So anything that's a final product will go here, and you can see here there's a paper. And let me just, well, we're going to see that main manuscript in a second, but that's the main manuscript. We also, for the analysis, everything gets output for, these are our basically lab notebooks. These get output as HTML documents. So let me go over first to the analysis, and I'll just show you one of these. So this is there's an organized data script or Quarto document. So this is our Quarto document that takes in the raw data and organizes the way for our analysis. I won't run this one because this one takes a little longer, but I will run the analysis one. And you can see it's actually got some of the output in there from the last time we ran this, which I can delete here. But this is our Quarto document. We'll talk more about what all these things mean in a minute. But what I want to do here is just I'm gonna hit that render button, and it's gonna run through. It'll take a second. You can see it's doing some stuff. It's processing. There we go. Now it's processing my code chunks. There we go. And in any second, we're going to see it pop up on the right here with the final document. There we go. So there's our final. We get an inline display preview of what the final document looks like. This is an HTML document, so you can open this in a web browser. And it's got some figures where we're doing some testing on the relationships. For example, this one we found to have a nonlinear relationship. Some model output. Here's some actual math showing how the models work. And then here are some tables showing off our model output and so forth, right? So this is basically our lab notebook of like what we did. This isn't the final paper, but this goes through what we did, goes through some sensitivity analyses and so forth. It's also set up so you can see that there is code, but it doesn't show you the code. But if you want, you can see the actual R code that produced each of these things is there as well to access. All right, so there's a ggplot producing that. Okay, so that's the analysis. Now we'll go over to the paper. Here's our paper. And so we have our code here, but we also have a lot of text for the actual paper. And then this is set up to render in a couple different formats. I'm going to go ahead and render it to my own format, PDF format. So again, we're going through the same process of now we're going to switch over to the LaTeX. You'll see it pop up with, because this one is going to render to a PDF. There we go. Now it's rendering the PDF. And there we go. So there's our final document as a PDF document. And you see it's nicely formatted. Got headers, we've got footnotes, we've got all these citations in here. All these citations were automatically put in. This one doesn't have actually any, which is odd for me. It doesn't have any figures in it, but it does have some tables. So there's a table. There's some math. There's another table. There's a model table, another model table. At the very bottom, we have a reference section, and this reference section is automatically created for us by the included citations. So just like that, we can produce the final document in a very nice format. Now, if you need to produce it in a Word document, because some journals only take Word, we can also do this to get it in as a Word document. It won't look perfect. You typically have to do a little work afterwards to clean it up, particularly like tables, but it will look, it'll get you 95% of the way there. In this case, we were actually submitting this to PLOS One. And so there is actually a template for a PLOS oriented PDF. So I'm gonna re-render the document using that format. And you'll see that it's going to look a lot different because it's going to follow the format of PLOS. There we go. So now this is what, if you ever looked at PLOS One or PLOS journals, you'll see this is what it looks like. So it's the same journal. Now, a couple things get screwed up here because what is PLOS likes? PLOS only takes these numeric citations, and we have noun citations. So that was something we had to fix, but it's not fixed in this version. But other than that, it looks the same. You'll notice one other thing is because of this offset, the table gets offset incorrectly. So it turned out when we did this, and what PLOS wants you to submit is a text file, not the actual PDF file. However, we set this up so that it actually output, in addition to the final PDF, it outputs the text file, the in-between text file, and then we could submit that with some corrections for those little issues. But basically, pretty quickly, we were able to turn this into a format that PLOS wanted for their journals. And you can find that there's a lot of updates. There's a lot of extensions that will allow you to follow specific journal formats when rendering your document. Okay, so that's an example of a project I'm working on. Now I want to show you a couple other examples here of ways you can use it. Let me find. That's our main thing. All right, let me go over here to this is actually a website. If you go there, you can go there yourself and look at this if you want. So I'll give you the link there in the chat. This is another project I'm working on, and we have this set up so we can actually publish it. And publishing is something we'll talk about on day 3. You can publish your results to a variety of different places to get them up on the web. And because I'm working with this on a co-author, we basically wanted to set up a and this co-author is not a local co-author. She's at Rice University in Houston. We wanted to set up a website where we could both make sure we were looking at the most up-to-date stuff. If I made a change or something, or she made a change or something, we could see it, both see it and have access to it. And so this basically takes all of what would traditionally be scripts, we have changed into Quarto documents, and then we just publish it. We publish all those here. So here's the organizing data script. This just goes through and reads in some American Community Survey data. We do some checks on it. There's some of our checks to make sure everything is coding how we think it should code, and so forth into the document. And then here's the analysis, where mostly we're looking at figures, trying to understand our results. You don't have to understand exactly what we're doing. We're looking at interracial marriage in this particular paper. At the bottom here, we actually produce the full output of the tables in case people want to look through it, but we're mostly focused on the models and trying to understand the models. Right, so all of our lab notebooks are basically published online right now. You can access them. So there's that. And then I also have some other publications. So Quarto Pub is one of the places where you can publish your results. And as it suggests, it's related. I think owned by RStudio or Posit, and it's easy to publish there, very easy. So some of the same stuff. So for the other project, the Hirsch project I was just showing you a minute ago, we published our analysis and our organized data script. We published that there so we can all access it. I have a demo of my own template that I've published for how things can look when you produce stuff in PDF. This is a fun one. This came about from a conversation at the conference with some colleagues about race reporting among Dominicans in the US. And so I just did some back of the envelope calculations and made this very small presentation that I could share with the people that were at that lunch meeting because I was just curious about it. And so that's what that is. That's the kind of thing you can do. It's amazingly easy once you know how to do this stuff. And then the last thing I'll show you is a teaching tool. So when I teach my classes, and these are for undergrad classes, we use a tool called Posit Cloud, which is, I don't know if anybody has used this. It's basically allows you, it used to be RStudio Cloud, now it's Posit Cloud because they changed their name. But it basically allows you to use RStudio interface in a web browser. But importantly, you can have these workspaces, shared workspaces that you can organize as classes, and you can organize projects as assignments. And so all the students basically in my class will be part of these projects or part of these workspaces. They will get assignments. And what I do for the assignments, so in this assignment, these lab assignments, they get a PDF or they get a Quarto document. And their job in this case, they were supposed to take 3 different pairwise comparisons, make a graph showing the relationship, and then describe the relationship in the text. Here we go. Well, just us follow instructions on Canvas, but and so I set them up with a template of this document, and then their job is to basically fill in the code and then write the description of the findings, and then when they do that, they'll render this document and they'll get a nice PDF document output that they then submit on Canvas. And so basically, I set these things up so students will, there's nothing here, of course, because we haven't done anything, but that's ultimately there'll be code there and there'll be figures there and there'll be their writings there. And so my students are able to use this too. Now, one thing you'll notice here is we're using a visual mode. We'll talk about that later. There's the source mode versus the visual mode you can use for your Quarto document. I give them the visual mode just to keep it simple for the undergrads. And I usually prefer to work in the source mode myself, giving more control over what I'm doing, but we'll show you both as we go on. But these are some of the ways we can use Quarto. Okay. So I hope that's whet your appetite. And we'll talk about how to put together a first Quarto document in the next section. Let's talk about creating a Quarto document. So I'm going to go through the slides here, and then we'll actually switch over to RStudio and do it in RStudio and show you how it works. So a Quarto document, like a basic R script, it's just a plain text file with the QMD file suffix. And the easiest way to do this in RStudio is just to go to File, New File, and then select Quarto Document. There's also an option for Quarto Presentation, which is just actually a special kind of Quarto document, but it's not like it's a different thing, really. But when you do that, it'll bring up a new document wizard, which you can see there on the left. And you don't have to worry too much. You don't have to stress too much about what you put in there because you can always change those parameters later. But it asks you for what output format you want. HTML, PDF, and Word are the defaults, although there are more advanced options. The engine you want to use, we're going to use the knitr engine because we're going to use R in RStudio. If you're a Python person, you can use the Jupyter engine instead to produce Python code more generically or more natively in a Python environment. But we can also do Python through the R engine as well. So we'll typically just use that. I'll show you how to do that at the end of today. So we're going to typically just leave the output format as HTML. That's the default. And HTML is the easiest output format to produce. It rarely will give you problems or errors. PDF and Word can be a little trickier. PDF won't work for you until you have TinyTech installed, which we'll talk about in a little bit. So right now, you can leave everything as HTML. And you're going to need a document that looks something like this on the left. And so let's talk a little about what the anatomy of a Quarto document looks like. There's basically 3 parts to a Quarto document. At the very top of the Quarto document, we're always going to have a YAML header. And that's going to start with 3 dashes on a separate line, and it's going to end with 3 dashes on a separate line. And that only happens once, right? So that always comes to the top of our document. And that is going to contain all the metadata information about our document. It's going to include all the options, all the format options. There's a lot of stuff that we can put in the YAML header, and you'll see from the example one that I have on our course materials, I have a huge one there, so you can see all the different options that you could do, not that you necessarily should do or need all of them in every document. We'll talk more about these in detail, but the YAML header to give us the metadata options. And then the second part is the markdown text. This is just the words. This is actually just writing text, not comments like you would write in an R script, but just raw text. And that text can be marked up with the markdown syntax. And you'll see in the example document here that there's a few little instances of that markup. But that's ultimately mostly just going to look like text. And then the third component is the code chunk. This is where it really makes it go. This is why we like it. This is what it does, is it allows us to integrate in these R code chunks and other languages too. We could do Python here. We could do Julia. We could do other things like Mermaid to get charts and flow charts and whatnot. And those R code chunks are going to contain executable R code. You'll see that in this example, and in most, this depends a little bit on what visual theme you have, color theme you have in RStudio, but the R code chunk should have a different background color than the text, right? So you can see here in this example that background of that R code chunk is light gray, and that's indicating to us that we have an R code chunk and tells us where we are. Are we in an R code chunk right now, or we're just writing markdown text? And that can be a good tool to see if, for example, maybe you forgot to put the closing fences on your R code chunk and you think you're writing text, but you're technically still in the R code chunk. That's a good visual cue to make sure you tell the difference between, am I in an R code chunk or am I just in plain markdown text? All right, I'm going to talk a little in more detail about each of these components. Then we'll talk about how to render it, and then we'll go and do an example. So let's start with the YAML header. So this is what the YAML header looks like in my first Quarto document. It just has 4 key value pairs, but in general, you can use this to write all kinds of metadata about the document. You can set a lot of different options here, so we can have YAML headers that are much larger than the one that you're seeing here. The basic syntax is going to be this name value pair. So name : value is how it looks. However, well, before I go in there, typically you don't need to put any kind of quotation marks on character strings. So you notice that I'm just giving the raw names of my document, my author name, and everything else. You typically don't need to surround characters by quotes unless you need to use something like escape characters for some kind of special character. There can be instances where you have special characters that could screw something up, and then you can surround it in quotation marks to make sure that it processes correctly. But here, this won't process fine without any additional quotes. The YAML header is also fairly picky. This is actually probably the most finicky part of a Quarto document, is the YAML header. And I had somebody who was one of the people who worked on developing Quarto, Allison Hill. I was having a conversation with her, and she said, yeah, whenever I have people with problems with Quarto, I'm like, it's a YAML problem. It's a YAML formatting. It's always a YAML formatting problem. Not always true, but often true. In my experience with my own students, this is often true as well. So for example, this little space here between the title and your name, that's required. If you just do title : and start writing the name of your title of your document without that space, the YAML header will complain to you. It expects a certain format, and if it doesn't get it, it complains. So just always check if you get an error. It's probably an error in your YAML formatting. So the basic name value pair is the easiest way to use YAML, but when we want to do more complicated meta information, there are a variety of other ways we can specify things using YAML. So often you want an array of values, not just a simple value. So this is an example with keywords. So if we have keywords for our document that we want to get shown in the display, we can list multiple keywords below so there's the key. And then below that, using dashes indented, we can write each of the keywords we want. So that's one way to do basically an array of values. The other way to do an array of values, same thing, is just to surround them on a single line, to use square brackets and then separate them with commas. That will also give us an array of values. You can also have complex objects and multiple complex objects, and those are displayed as a different way. So the most typical way you'll see this is for authors. So I just had a basic author and then my name before, but if you have multiple authors, instead of doing that, you can use a dash like we did here with an array, but then that author field has multiple keys itself. And I'm just using 2. I could use a lot more here. Start with name, and then the next one, email. You notice I don't have a dash here, but it's on a different line indented. And I can keep going with other stuff, org ID, address, web. I think I forget what I think web address. I forget what we have. It's in the example document. You can give a email or a website address and everything. So these are probably the most complicated ones to use. And the most common way you'll use this is for author fields. And tomorrow I'll talk about all the different fields you can put in for authors, because that's probably the most important thing when you're writing a research document, is to get all that author information in there correctly. And then last but not least, you can have a nested structure. So you can have keys within keys within keys. And so in this case, we have a format key, and the format key is telling it what format should this be rendered to. Should it be rendered to HTML? Should it be rendered to PDF? Should it be rendered to a Word document? And I could just put HTML there, which is what you saw in the previous slide. But here, I'm going to actually indent HTML, and then I'm going to put a colon on HTML, and then give a variety of arguments that are specific to the HTML format, or specific to how I want that HTML format to be rendered rather than other formats. In this case, self-contained means everything is going to be in a single HTML document without any depending files that are external to the HTML file. And we'll talk more about what that means again tomorrow. So you can put multiple. So if you want HTML and PDF, you can put HTML and then you can put PDF on a separate indented line, and it would do both of them. And then they can have their own nested structures. So this nested structure can go on indefinitely. Okay. Let's talk about the Markdown text. So here's examples of Markdown text. We're going to go through what the Markdown text looks like in detail later, so I'm not going to go too much into it. But the basic idea is it's a very easy to learn and, importantly, easy to read markup system. And so you see there's a couple features that have been added here. We have headers. So this is how we specify headers. These are second level headers because of the $2 or 2 pound signs. So these are going to display as headings when we render this document. And then we have a bold. We're bolding this by putting 2 asterisks around it. And that's really all the markup we're adding to this. Technically, I guess you could consider this markup because this will actually create a link. But that's it. And you can see it's not hard to read. So that one of the goals of Markdown, and one of the things it does really well, is that you can write in it without breaking up the flow of reading it. It's easy to read. A lot of people have more problem with LaTeX, unless you're really familiar with LaTeX. Like the syntax can get in the way of your being able to read and edit it. That's not true for Markdown. So we'll talk more in detail about all the cool features of Markdown. Very easy to learn in a little bit. And then here's the code chunk. So this is a very, very simple code chunk, a kind of pointless code chunk, but nonetheless a code chunk. And that's going to contain executable code. In this case, executable R code. And the way you indicate a code chunk is with fencing. So the fencing are these three little reverse apostrophes. They are, my students in my class wanted to know what they were called. And according to them, after extensive Google research, they are grave accents. So that's what we call them, grave accents. And on an American keyboard, you'll find them immediately above the tab in the upper left corner of your keyboard. And so we do 3 grave accents to start, 3 grave accents to close. And then after the start, in curly brackets, we're going to include what kind of code we're running here. So when we're running R code, it's just always going to be lowercase r. But if you wanted to run Python, you would write lowercase Python here. If you were running Julia, you'd write lowercase Julia. If we're doing a mermaid graph, we'd do mermaid. And you can mix these in. So the same document can have multiple different kinds of programs it's running. You just can't run multiple programs in the same code chunk. So you have to do them in different code chunks, but you can run multiple programs within the same document. Okay. Just notice no space. It just the curly brackets come right after the code fencing, and that will tell it that we are in a code chunk. Now, if you're used to R Markdown, or you've seen R Markdown, you'll know in R Markdown, in that curly bracket, you would also include all of the code chunk options and arguments that you want that are specific to that code chunk. That is no longer the case in Quarto. So that code chunk that curly bracket will never contain anything but the name of the program you want to run. In Quarto, if you want to give specific code chunk arguments, you give that immediately below the beginning of the code chunk before you run the code. And these are always going to start with a comment sign and then a pipe. And then you're going to give the name of the argument and its value, just like you would in a YAML header. It looks same kind of syntax. In this case, I'm telling it not to echo the code chunk. So that means I don't want it in my final document. I don't want the code chunk to show. I just want the output to show. Okay. And there's a variety of arguments. We'll get into all the different arguments that you can put in here, options for that are code chunk specific later today, and we'll see more of them over the next 3 days. You can add a lot of customization here to the code chunk through the code chunk parameters or options, but all those go immediately below the initial code chunk. Okay, and as I said, I think I said this earlier, but when you're looking at this in RStudio, code chunks will be shaded a different color than the body of the text. So you'll always be able to tell when you're in a code chunk or when you're not in a code chunk. Okay. So when you're looking at a Quarto document, you don't have to render the whole document to make sure your code is working. You can run your code chunks interactively. You can run them by just putting your cursor on them and hitting the run button. But you can also just run an entire code chunk by hitting that little green play button, as you see I'm doing in this example. And that will run the code chunk, and it will show you an inline output of what your inline display of what your output is going to look like. In this case, it's going to look like a figure, not a terribly interesting figure, but a figure nonetheless. So generally, you're going to do a lot of interactive work with your code, with your Quarto document before you bother rendering it. But when it comes to rendering, well, that's as simple as just going up to the top of your Quarto document and hitting the render button, as you've already seen me do. You'll see some information pop up in the lower left panel. And then you'll get the output displayed, preferably inline. Now, one thing I will tell you is
unless you set your options, you're typically going to get your output displayed as a pop-up. It'll pop up out of RStudio rather than this inline display that you're seeing here. Oh, there we go. We got the tip. I would recommend the first thing I always do if I have if I get a new version of RStudio or new computer is go and change your preferences in RStudio under the R Markdown tab to show output preview in viewer pane. And I'll show you how to do this in a second. So you always get that inline display rather than the pop-up.